Docker. Why do we care about this thing? Um, so Docker, it automatically sets up like our coding environment to run software or a process. All right. You can see like it's very, very popular. Like 35% of programmers use Docker, which is beats AWS, by the way, and like a Mac. Um, why, how is something like this so valuable, just like setting up our environment? Well, one, like a lot of you all might have now at this point, like for your internships or just for fun, like try to use software from GitHub, right? Just like clone down some stuff from GitHub. Like for instance, like you can clone down this platform called Ghost, which is very, very popular. Um, but if you think about how you're going to get Ghost up and running on your computer, it requires like a number of things, right? It's going to require, the right backend programming language, right? Like whether it's Ruby or Python, the correct database to be running. If React, right, some sort of JavaScript library is necessary, well, that needs to be installed too. And all of these different pieces of software, you better install like the compatible version so that they can properly talk to each other and also talk to the code base, right? So it's beyond just having, people oftentimes compare this, or a lot of students will like ask, well, isn't this just like, our pip or requirements.txt? Yeah, but imagine now, like requirements.txt presumes that we already have Python installed on our computer, right? What if this website's written in Java? We need to make sure that's installed, right? So it's really all the components of the environment, of the coding environment that's necessary. Ideally, that each of those things will be contained in the Docker universe, okay? And that makes it a lot easier to just, get a piece of software up and running if everything, is just like maybe run a simple command and then all the different components are on our computer talking to each other and working. Another reason why this is like so valuable is just if you think about the modern like workflow in web development or engineering in general. This is the way it works. Probably obvious to you guys. You code on your laptop, and then as we know, like we're going to need to push our code and make sure everything works on production, meaning on AWS, right? When we do that, we need to make sure that we want to make sure that our development environment, our laptop, the environment that we are coding in, is very similar, if not, it probably can't be identical, but very, very similar to our production environment, right? So if we have a technology whose job it is to set up a coding environment or like an environment for a process or soft piece of software to run, right? Then we can maybe encode, say, hey, here's everything that we need. Here's everything you need to download. Let's download it on my development environment. And then when I push my code, those same instructions will be delivered to the production environment. And that will ensure that we in fact have very similar environments, if not identical. Okay? So, right, so like obviously we know like the end user isn't hitting our laptop directly. We're coding on our laptop, we're pushing up to production, and then the end user is connecting to that. And, in a modern like web shop or engineering team, we want to be able to do this as seamlessly as possible, right? Like we fix something, there's a bug, we fix it, we push it up, right? And we don't want to find out later on that, oh crap, it worked on my computer, but it doesn't work in production. Not only does that cause problems for the users, it's very painful to figure out what's going on in production that's not going on locally on your computer. All right, so these are some of the reasons. We'll see more for like why Docker is so valuable. But essentially, what it allows us to do is just set up an environment and all the tools to run a piece of software. All right, so let's start with Ghost. We can use Ghost with Docker. Unfortunately, like we're running into a few version things today. The latest version of Ghost is a little harder to run, so we'll use a previous version of Ghost. We can, and by the way, right now I'm just going to give you like a whirlwind tour of Docker, all right? And then we'll go through each of these steps. So you can see I already have Docker installed on my computer. I do Docker V, and it's up and running. The other thing to look for is just make sure that this little boat thing, there's no, when it stops moving and it's up there, then you know that Docker is running on your computer. If it's not running on your computer, just press like Command Space and look for Docker if you have a Mac. Or you can, just double click on Docker and eventually you should see this icon start up. It will like these boxes like move around until eventually they stop, and that's how you know Docker is in fact running. All right. So if we want to get Ghost installed, like the first thing would be get it onto our computer, right? Download the software. Then we'd have to worry about getting that software up and running. So to download the software, we'll do docker pull. And normally you can just do docker pull Ghost, just like it says. We'll want that earlier version, so we're going to do :4.8.0. All right, and this is in the reading. You can see I already have it on my computer. If you do some sort of software that you don't have, I'll just show you. You see this? It's downloading all this from the web. Okay? And it looks like, in fact, it's like making multiple downloads. We are cloning down the Ghost image, which we'll talk about what that means. But it looks like there's like these sub images, right, that are part of this larger image. And so we'll talk about that. If I do docker image ls, you can see that I have a few images on my computer. We'll be using this one, this Ghost version 4.8.0. The way I can get this thing, so what I just did was I downloaded the software onto my computer, just like when we downloaded VS Code, right? Now we're going to double click on like VS Code and just get it running. So again, here's the software that we're listing. If we want to double click and get it running, we have to do docker run Ghost : 4.8.0. Okay. Take a look. It almost looks like, right? It looks kind of like Flask, right? Ghost is running in production. Look at this. It's creating various tables for us. So not only like downloading, right, using the right database, but also doing the setup in terms of creating the related tables. Any permissions, right, are set for us. And look, it did some sort of scheduled job, like a cron job, meaning like, I guess every week or day it does something. Maybe it emails people. Potentially it does that, right? So a lot of things are just happening for free. And it tells us that this is running on localhost 2368. Let's go here. That's not going to work. All right, so this says the site cannot be reached, which is confusing because right here, it says it is available. So let's shut this down. And this time what we'll do is docker run Ghost 4.8. And we're going to add this flag for -p. It was port 2368. We're going to map 2368 to 2368. That's fine. I'll try this again. There we go. Okay, it's starting up. There we go. Okay, so this is like part of the power of Docker. It's just like with a few keystrokes, right? We can get like production level blog, like website up and running that has a lot of different dependencies, right? Of course, like what we need to unpack is one, like what is this image thing? When we booted up an image, right? When we downloaded an image. So we kind of see this by doing that docker pull Ghost : 4.8.0, right? That downloaded our image, whatever that means. And then from there, we need to run that image in something called a container. So if image is like the software we download, the container is the running instance, is the way we refer to like that software running. Okay. So we did that with docker run Ghost : 4.8.0. Then we saw running it didn't actually make this accessible for us, right? When I went to 2368, it's not there. The reason why is we had to, again, we're going to have to go through this, but we fixed this by then doing that, what's called like a port mapping. So we did docker run -p 2368 to 2368. Okay, and now this will be available. Okay, so once it boots up. All right. So, you can kind of see different things, right? We have to talk about an image. We have to talk about a container. We have to talk about, like, why do we need to do this? Why is this thing not available unless we run this command? Like, why is that? Okay. So let's go through these different things. A good way to do that is just to see, like, how Docker is set up. So let's talk about it. All right. So again, like Docker, we use it, because to basically download all the dependencies to get a piece of software up and running, and ensure that it really works every time, which is a dream. It doesn't necessarily happen, but a lot of the times it does. So a way to think about why Docker and how it works is to go back before the days of Docker. So before Docker, you would use a virtual machine. Some of you have probably used one, right? So you can see what I have here. I've done this before. You would have like a Mac, and then on your Mac, you download Windows, right? Say you have some software that only works on Windows, right? You can have Mac, you can have Windows installed on your Mac laptop. So just to get a couple terms out of the way, this is called the host. The host computer is like directly interacting with the hardware. That's your Mac. And then the guest is this Windows, right, that sits on top of it. So why would you use a virtual machine to start some, why would this be, how is this related to Docker? Well, if you think that Docker sets up your environment perfectly so that a piece of software just works, one way to ensure that, right, before Docker would be, let's download Windows and basically boot it up, and then from scratch, make sure we follow specific instructions, right, to install each step. This way we make sure, only what we need is on this Windows. There's not going to be it's not going to conflict with anything else. We're just going to directly follow the steps that it tells me to do to get this thing working, right? So you start with a pristine, clean room, right? That's our virtual environment. And then you slowly add software that we read from some instructions until we have that, in this case, Ghost or whatever we want to run, we have it actually working for us. So, this is something that you could do, right? And we could probably ensure, hey, if we just kind of follow these steps. But there are obviously some downsides to this. Even if we do this perfectly, right? Having an entire operating system just to get another piece of software up and running, that's pretty costly from a space perspective. One way to think about this is, imagine you have a web application and you have a virtual environment just to install the database, install the right versions of any JavaScript libraries and Python, etc. To make sure to eventually build up our website. So that would be one virtual environment. And then let's say we have also a chat application. It's very possible that you want to isolate those two things. And so that means you need a separate virtual environment for the chat application, right? So it's each component, each kind of separate application of our website would need its own, its own virtual environment. And that could be take up a lot of space. The other thing is, if you ever booted up Windows, it's been a while for me, but it takes some time, right, to start up an entire operating system just for the purpose of, booting up a website or launching some piece of software. So, right, this is costly, mainly from a space perspective, but also from a time perspective. So anyway, what's Docker supposed to do? We want an isolated environment. This way, my chat application is not conflicting with my web application, right? And any other software on my computer is not conflicting, right? Anything, right? We've seen with different versions of Python or whatever, have different pip libraries. There's the potential for conflict. So we want an isolated environment while not being as costly, right? From a space requirement perspective of using a virtual machine. All right, that's really our goal. Okay? So Docker is pretty clever in how it achieves this, right? So again, the goal, we want an isolated environment for each individual task without creating a separate virtual machine. It uses this thing called a union file system. This is a feature of Linux, okay? And a union file system has two different, benefits that is useful for us. One is let's say that we have we want our Harry Potter books, and we get one Harry Potter book from a CD, like in those old days, we borrow a friend's CD, and another one we have on our hard drive. So the Union file system, one like feature of it is it can make it look like both of these books or both of these sets of files are under the same folder, even if this lives somewhere else. Okay? So like you can kind of see it helps us share different pieces of technologies, right? And makes it look like, okay, if I have Python 3 is used by my chat application, it looks like it's also, over here used by that blogging application. All right? So that's kind of one benefit. A problem with this is, okay, if these two different things are using the same software, one of them may want to edit, right, the book. So sticking with this analogy, we borrow Chamber of Secrets from my friend, right? We plug in the CD, and then all of a sudden I'm like, I want to change the first page, right? Because I think I can make it better. If we change the first page, right, our friend will be angry, right? So instead what we do is we copy that first page, right? And we edit the copy. The Union file system will know that this file is the edited one, and it will use the edited version here, but not change the underlying version. So for me, it looks like I've changed the file, but really I've copied the file and I'm reading the copied edited version. All right? So this is really valuable, right? Because if you think about like my chat application and, the blog, well, we can change, a library or, something, right? If we code along and change something, we can change something in the blog, but really that change will really be a copy, right? We're just really copying the file and then writing to that file and not actually changing anything that the other piece of software depends on. All right? So that's really valuable. It allows us to save space. It means that we don't need to have two separate books or two separate softwares on our computer, but we can still modify them safely, right? Modify them without affecting anything else that depends on that software, right? So this is called copy on write. I'll just write that down. Copy on write, meaning that if you were going to change something, you first make a copy to it. Right, and this saves a lot of space, as you can imagine. So the contents are, right, with the Union file system, the contents are read-only. Any changes made are first by copying the relevant file and then making edit. So again, like we can have one version of Python, like Python 3, and then if any piece of software, like, changes it or changes any library, it's really what it's doing is making a copy and then editing that copy and not the underlying version. So that's what this stuff is. These are all these like little images. These sub images can be shared by other softwares, right? This could be maybe shared by, like, maybe this represents Linux and this represents Python and this represents, Flask, right? If I need these three things for my chat application, it's okay. Like these can be shared by the other application, right? And if Ghost ever alters anything here, it's really just first copying it and then altering it. One thing to note, so these things are called images, right? And then, like, as we said, the software, the overall software that we downloaded, this is also, an image. What is an image? It's just, it's just files that are in layers, all right? So here's one way to see it. This whole thing is an image. Right, here's the kernel, and then here's, Ubuntu, right, which is like Linux, and then here's Emacs, and here's, Apache, right, the server. And then finally, you have the container. So the container is, right, when we boot up our website, there's our container, and you can imagine, right, that when we boot this thing up, we are like, we might interact with this website, like click around and like write a log file, like record that, hey, this person clicked here, this person clicked there. So all of a sudden it seems like we have to change something. Somebody signs up, we have to save that somewhere, right? So it seems like we have to, actually make some changes. That's this top layer where we like, save our user, right? All those types of changes are happening in the container layer. Okay? So this is where, right, when we're running, when we're interacting with something, we're making changes, that's just another layer on top that we can write to without affecting any of the underlying images. This stuff is confusing, like going through this stuff, but that's the main technology, right? An image, what is an image? The image is just like a layered set of files, right? It is the software that you download, right? When we downloaded, Chrome, like Google Chrome, right? We just downloaded the files on our computer. We can have multiple instances of Chrome running on our computer. Each of these things are kind of like two separate containers, right? Where this is us running the software. Okay. Then the last thing is just, Docker also takes advantage of like namespaces, meaning that, we can see that when we boot up Ghost, we're using port 2368. What if the chat application also uses port 2368, right? It would break. We only have one of those locations on our computer. So instead what happens is each one of these processes, right? When we boot up Ghost, you can imagine it's in this like virtual container. And this container has its own port 2368. So when I try to access, right, when I just run Ghost and I try to access port 2368, and then we go here, 2368, it's not available, right? The reason why is because, again, Ghost is like, or Docker is basically saying, hey, I can't just allow you to occupy the host machine's port, right? Because there might be another application that's using it, another container. So instead, you'll occupy the container's port, and if you want this container port to speak to the host machine's port, we can map it, all right? So what we'll do is we'll say docker run and map port, and I think I always get it confused which one's first. I think it's the host machine first. Yeah, it's the host machine first to the guest machine. So look at this. All right. So now it says it's running on localhost 2368. This doesn't work. Why? Because this is the guest machine. This is the virtual environment or the container. It's running in 2368, but we're mapping port 2368 to my host machine's port of 2369. Right? We're doing that wherever I first ran this, right here. Yeah, 2369. So if I go to 2369, that works. You got it? So again, right, Docker's trying to keep everything isolated so that there's no conflict with one another. So when you are running a process, really what you're doing is you're running it inside of a container, and then you can expose that process, right, to the host computer. Anything to like fill in? I know that this is confusing.
So is there no way to access, like in our case right now, Ghost, without having to map it to a port in our host machine? Can we just do it within the container somehow?
No. No, I mean, not that I know of. At least you're not supposed to.
Or
Yeah. So it's purposely, you can imagine that maybe there's a lot of processes running to get, Ghost up and running, and only one of them do you want to really expose, do you need to access directly, right? So here you're being like pretty specific about, okay, what are you exposing, you know?